All right, so let's crank through the exam. So this exam is hard. It is like exam 4. 4 and 5 are usually the lowest average. You guys did well on 4, so I'm hoping same thing for number 5. These questions are tricky. Here we go. So I don't really have room for this one here. Let me bring it over here. 9. And notice how the powers aren't very high. It's the test generator. It doesn't do a very good job on the powers. You can barely tell that 7x is like a power. So look close. Anything that's up even a little bit is a power. So that's a power. 9 to the 7x power is 81. How do we solve that? Yeah, remember what we learned? When x in the power zone. Remember I did a whole history story, Hitler and Stalin climbing into power. So I'm trying to help your memory, because I know it's hard to keep it all straight. I know when you get a math exam, it's easy to kind of say they all look alike. It's hard to tell which one. So x in power. That's like Hitler, Stalin, get into power, try to key your memory. What do? Number 1, make the bases the same. Well, I should say try. Try to make the bases the same. So try that first. Can I make those two bases the same? Yeah, 81 is 9 to the second. So now, once the bases are the same, like that, what could I now do? Yeah, just say bye-bye bases, and 7x must equal 2. Right? Because if 9 to something is 9 to something, those somethings must be equal. Or 9. If they were not equal, then 9 to one of them wouldn't equal 9 to the other, would they? If they were different. Those powers have to be equal, because 9 to one of them is coming out equal to 9 to the other. So those powers have to be equal, don't they? Then divide by 7, x is 2 7ths. See? Good? Easy there? So if you have x, notice that's x in power. Didn't I do the whole story? Hitler, Stalin, right. So I'm trying to key your memory, right? I tried to say, there's always people with crazy views, like Hitler's crazy views, but the problem was he got into power, right? So I'm trying to remind you, when x is fine, whatever, but when x climbs into power, that's what's really difficult and we have to do special things for. Y'all hearing me on that? Because I'm trying to help your recognition when you see that exam day after tomorrow. Specifically, not just that there are powers, but that x itself has climbed into power. Everybody see what I'm saying? That's what I'm trying to, I hope you'll just remember and go, oh yeah, that's the special thing. X has actually climbed into power. Try to make the bases the same. Okay, that's good for number 8. But now, whoops, it's not what I wanted. Now on number 9, we have 10 to the x is 18. So again, x in power. When x actually climbs into the power zone, that's real challenging. First thing is you try to make the bases the same. Try to make the bases the same. Can we make those bases the same? No way this time, huh? 10 and 18, there's no way to do that. So, okay, what do you do when you can't make the bases the same? I did that whole memory thing. I'm hoping somebody remembers. No? No? I'm going to cry up here. No? Yes, thank you, Abraham. Thank you. You all know, you're just being quiet, huh? L in both sides. Yeah, so if you can't make the bases the same, you L in both sides. You L in both sides. So you L in this side, L in that side. Does that make sense? So when x climbs into power, trying to give you the impression that's a big deal, and you try to make the base same. If you can't make the base same, got to L in both sides. That's hard to remember because there's where did that come from? There's no L in anywhere. So that's why I'm being real specific to try to help you remember, because it is hard to remember. Because it's there's no L in there. Where'd that come from? L in both sides, and then what? The power can come down, and then we'll divide, yeah. That x comes down. Remember the rule of logs? Remember that third property that says powers can come down to the front? That's true for a regular log or an ln, any log. It's true. That's why we did the ln thing, because we wanted to get Hitler out of power. That's why they tried to assassinate him so many times, right? Because they wanted to get Hitler out of power. You want to get the x out of power. You got to get it down to the base zone. And now it's cake. once the x is no longer in power, it's pretty easy. Just divide by ln 10. Just divide by ln 10. There it is. Does that make sense? Once x is out of the power zone, it's not hard anymore. That good? So it's just ln 18 over ln 10. Just divide those. You guys have your calculator? I got my calculator. Let's divide those. Make sure you can get that answer. 1.255? 1.255. Which one of those is that? Is it none of the above? Yeah. Oh, so it should be. But still, anyway, it's not even close to any of those. So it must be none of the above. I'm going to get the answer key out. Because none of the above, I don't know about you, but none of the above makes me nervous. Number 9. D. Oh, no, it's wrong practice now. Oh, yeah, I don't have the right. I'm doing number 4. I don't have number 5. I haven't filled it out. So, you guys have the answers, right? Here, I can flash to the end. Since it's a 10 log.
Since it's a base of 10, you can just do 18 log.
Yeah, you're totally right. You can totally do that. Yep. That works good too. So it's none of the above.
All right.
A to Z. Good? Everybody good with that? So when x climbs into power, try to make the bases the same. If you can't do that, ln both sides, right? On we go. Okay? All right, double logger. How do you do a double logger? So log x minus 9 plus log x is 1. What do you do? Yeah. So remember I called it a log countdown. There's a lot of hard things to remember on this test. There's a lot of different things we did. Yeah, 2 logs, 1 log, no log. Log countdown. So right now I have 2 logs. So as soon as you see like the double logger, you should think, oh yeah, log countdown. So 2 logs. Next line, you're going to make the 2 become 1 log. What happens when the 2 become 1 log? Those properties, right? Remember the properties we learned? 1 log, I'll put over here, properties. Well, maybe I should put a little more to it than that. I don't have any room. I need a fresh screen here. I'm going to do that. Number 10, what is it? Log x minus 9 plus log x. Log x equals 1? Yeah, equals 1. Okay, yeah. So log countdown. So there's 2 logs on this line. I'm going to have 1 log in the next. Adding becomes multiply. Subtraction becomes divide. Remember the property thing? 2 logs added is going to become 1 log what? Adding becomes multiply. So x minus 9 times x. And the equals 1 is just sitting there. Is that good? Remember those properties? How adding goes with multiplying, subtracting with dividing, right? Okay, so now it's 1 log. And next line, no log. That's why I call it a log countdown to help you remember. Log countdown. 2 logs, 1 log, no log. Okay, how do I go to no log? Good. Yeah, remember what's going to happen now? I'm going to cross off the log. That's how I'm going to go to no log. When you cross off the log, or lose the log, base stays the base. Remember that whole thing? Other 2 switch. Other 2 switch. So the base stays the base, the other 2 switch. What's the base? Good. When there's no lower down number showing, it's 10 for the regular log word. It's E for the ln word, isn't it? Okay, good. So stick in the 10. Cross off the log. Base stays the base. The 10 stays the low down part. And all the x stuff and the 1 switch positions, don't they? Instead of 10 to all the x stuff, it's 10 to the 1. And all the x stuff goes to the other side. Like that. Is that good? How are we doing? And now we can just solve it. 10 to the 1 is just 10. Distribute the x. X squared minus 9x. We good to there? Now what do we do? How do we solve that x squared equation? Yeah, whenever you have, you know the game plan, whenever you have x squared, it's step 1, get a 0, step 2, factor, right? So, yeah, so jump the 10 over here. X squared minus 9x minus 10. So get a 0, and then factor that thing. And you're trying to say, okay, what are two numbers that multiply to be 10, add to be minus 9? 10 and 1. Sign in the middle goes on the bigger, minus 10 plus 1. And so then the answers are positive 10 or negative. Remember, it's opposite signs, right, from the parentheses to the answer. So now, are those our answers? Got to check. Remember, with logs, must be checked. Any log question must be checked. But it's a super easy check. Usually the negative one's no good. But that's not quite the whole rule. The rule is plug into the original. You cannot have no negative, no 0 inside any log. No negative, no 0 inside any log. So if I put in 10 here and there, does that make the inside of any log 0 or negative? No. 10 minus 9 is 1. That's not 0. It's not negative, and so that's not a problem. But the negative 1 is a problem, isn't it? Negative 1 minus 9, that's negative. Stop. He's no good. So the answer is only the 10. Only the 10 on that one. We good? Remember the logs? So log countdowns. 2 logs, 1 log, no log. Use the properties. Lose the log. All right. So number 11. So they want me to take that log and break it. We didn't do this one? This one looks familiar to me. Break that into 3 logs. So I'm going to say, okay, here we go. Break it into 3 logs. So the log base 8, log base 8, log base 8. That's not changing at all. So log base 8. So of the 9th root of 17 minus log base 8 of q squared minus log base 8 of p. Everybody okay with that so far? Oh yeah, we had this one as a quiz. I remember. Abraham, this was your favorite question, I remember. Yeah. Quiz. You remember it now, huh? Yeah. Those are both minus. Right? It's an easy mistake to say, hey, these guys are multiplied down there. Yes, but they're both in the denominator. So they're both subtracted, really. Remember, dividing goes with subtraction? They're both divided. They're both denominator.
If it was multiplying on the top, it would be plus?
Yeah, if it was on the top, if that p was up here in the top, that would be plus. Exactly. Very good question. Is everybody good with that? Any items in the top are plus, because multiplying goes with adding. Any items in the denominator are really divided, so that goes with subtraction. So the p is on the bottom, which is really dividing, so that goes with subtraction. Good so far? Last thing, what does this 9th root do? 1/9 power. 9th root is a 1/9 power. Remember that? Well, there's actually one more step. Huh? And then, what do you do with powers? Comes down to the front. And so, we got it. Whichever answer is right. So B? There it is. Is that good? Questions on that one? We okay? We're happy with that one? Questions I can answer? All's good? Okay, number 12. Why don't you try number 12? Take a step or two on number 12. I think you'll get more out of it if you try. Just try to begin it first. First couple of steps are important. So try number 12, just first couple steps. Okay, number 12. Number 12 is a greater than, less than question. Notice that this one and this one, 12 and 13, are both greater than, less than kind of questions, and they're the only ones on the entire test. So I'm trying to do like I did with the Hitler thing. I'm trying to help you with recognition. I think that's a lot of the battle. If you see, oh yeah, that's special, right? That's not an equal sign. That's a greater than, less than. That little symbol makes a huge difference, which means there's a whole special process for these kind. So you want to recognize there'll be two on the real test, same kind of way. One that's not a fraction, one that is a fraction. It's exactly what you'll get on the real test Wednesday. So what do you do when you see greater than, less than kind of question? Well, we had a whole process. Step number 1, we said change to equals and solve. Change to equals and solve. Step number 2 was denominator only equal to 0 and solve. Denominator only, all by itself, equal to 0 and solve. Of course, in this one I don't even have a denominator, so I won't be doing step 2 for this problem, but I will for number 13 in a minute. Step 3, number line. Remember the number line? It's either true, false, true, or false, true, false. You're going to put places on the number line. Remember that? And it's going to be like true, false, true, or false, true, false. Something like that. You have to check. Check. One section. Check one section. So that's what we need to do. It's this whole special process. So it's easy to forget, easy just to fly over. Because we see so many x-squared equations, huh? You can be tempted to just do what we normally do, which part of that's all right, but you'll be confused at the end. All right, so let me go up here and I'll actually solve the problem. So come on up there. So let's bring it up here. So p squared plus 3p minus 18 greater than 0. So what am I supposed to do on step 1? Change to equals. So step 1, change to equals and solve. So how do I solve that? Just factor, right? Like that. What multiplies to be 18 and adds to be 3? 6 and 3. 6 times 3 is 18. How do they add to be plus 3? Yeah, plus 6 minus 3. Is that good? Adds to be. Sign in the middle always goes on the bigger, right? 6 is the bigger one. So the sign in the middle, the plus here in the middle, goes on the bigger. Okay, and then, and you know that means negative 6, positive 3. It's always opposite sign from parentheses to answer, right? I'm skipping the step of setting them each equal to 0 and that whole thing. So we get to here. Now, most people remember that much. Most people, even if they don't think of this, they look and they go, oh, it's got a 0, it's x squared or p squared, I'm going to factor, and they get down to here. And then they freeze up like a deer in the headlights. The car's coming. They look at these and they go, uh-oh. All I've got is minus 6 and 3. They all have a minus 6 and a 3. Well, almost all of them. What am I going to do? Which one's right? That's when you got to have the number line thing. So you got to do the number line thing. What does that mean, do the number line thing? Well, we've got to put those two answers, let me erase this, on a number line and then test which region or regions are the right one or ones. So here we go. I'm gonna draw a number line. I'm gonna put minus 6 and plus 3 on the number line. By the way, I've seen over the years, I know it seems silly, people will go 3 and minus 6. Watch out. Don't get those backwards because that'll mess everything up. You know, negative, put them in their real order. Negative 6 comes before positive 3. Okay, so now it's either going to be true, false, true, or false, true, false. It'll switch back and forth. Whatever it is, it just always switches back and forth. And our answer will be the true sections. We're always trying to find the truth, right? So you got to. So really, all you have to do is check one section, and then you'll know what they all are because it just switches back and forth. So where do we check? Really, anywhere you want. What's the easiest number you know? 0. So I just go wherever 0 is. 0 is right here, isn't it? There's 0. So I'm going to check x equals 0, or p equals 0. So what does that mean, check p equals 0? That means literally take the equation, p squared plus 3p minus 18 greater than 0, the original, before I changed it to equals, and plug in 0 and find out if it's true or if it's false. I'm like an electrician checking the line to see if it's hot, if it has power in it. I'm checking and sticking my wire in saying, is there power there or not? Is there truth there or not? And so when I plug in 0, 0 squared plus 3 times 0 minus 18 greater than 0, these are all 0. Is minus 18 greater than 0? No, that's false. So this section is a false section, which means this one's true and that one's true, right? True because it switches back and forth. So true, false, true. Good so far? So the answer is the true sections, this section and this section. Those are my answers. Now, how do you say that? What notice they're not saying it with an X like the homework did. The homework always did it with an X, but they're doing it with interval notation. We've had both before, so you're okay with that, right? So interval notation means you take the chunk that is shaded and you go left edge, comma, right edge. And then this chunk that is shaded, and you go left edge, comma, right edge. That's how you specify the shading chunk, left edge, right edge, of each chunk of shading. So what's the left edge of this chunk of shading? Negative infinity, because it goes left forever. That's what that arrow means. And what's the right edge of this chunk of shading? Regular infinity, positive infinity, because it goes right forever. So it goes from plus 3 to infinity, from negative infinity to negative 6. So negative infinity, negative 6, and then 3 to infinity. There it is. See how that one's right? Plus, not only that, we had 2 chunks of shading, so there has to be 2 separate parts to the answer, doesn't there? Is that good? Questions on that? That one's missed by most. No, I don't know, most is right. Many. That's one of the most missed questions. How about that? The greater than, less than ones. Is that okay now? Because remember that whole number line thing? Let's try number 13. So go ahead and give that a try. 13, we got the 3 steps. Step 1, change to equals and solve. So that'll be cross multiply, right? Put the 3 over 1 and cross multiply. And you'll get one answer. And then denominator equal to 0 and solve. And you'll get the other answer. Both answers. So step 1. Step 1, change to equals. I changed to equals there. So that's equals now. Put this over 1 and go diagonal, diagonal. To solve that, we good? Change to equals and solve. So 1 times x plus 11 is 3 times x plus 6. Is that good? And then whenever you have the x's on opposite sides like that, you got to get rid of one of them, right? Gonzo. 2x plus 18, like that. Subtract 18. And then last step is divide by 2. So minus 7 halves. So we got x is minus 7 halves. So that's all step 1. Step 1 said change to equals and solve. So we just changed to equals and we just solved. Yeah, now on to step 2. What do you do in step 2? Only the denominator, nothing else, not the numerator, not the right side, not anything else. Only the denominator equals 0. So just grab the denominator, nothing else. Just the denominator, and set it equal to 0, and solve that. Right? If you go back here, that was step, well, I erased it now, but anyway, that was step 2. So step 2 is just the denominator, nothing else. Move that over, negative 6. Only denominator. All right, so until we got 2 answers, right? And which, of course, you see all those answers, negative 6, negative 7 halves, negative 6, negative 7 halves, 6, negative 7 halves. So you see those answers those are the 2, but now to know which of those is right, you got to put them on the number line and do the true, false, true, or false, true, false thing, right? So go ahead and put those on the number line. To help you know where they sit relative to each other, which one's bigger, smaller, I would divide this one on your calculator. So negative 3.5, this one is, huh? 7 divided by 2 is 3.5. Half of 7 is 3.5. So that's negative 3.5. Be easier to put on the number line, I think. So put those 2 on the number line now. And then test. Like an electrician checking for power, you're checking for truth. Give you a second to do that. Okay, so I'll go up here and do that. Get that out of the way. Okay, so we're going to do the number line, put those on the number line. Negative 6, and then negative 3.5, negative 7 halves, in other words. Like that. So the negative 6 is further to the left. Where's 0? Over here on the right. So 0's not always in the middle, notice. 0's wherever 0 is. And in this case, 0 is to the right of both those. Those are both negative numbers, huh? They're both in negative territory. So you don't have to check 0, but I think it's nice and easy. So I'm going to check x equals 0. Where do we check anything we check? Always the first step, huh? Always before we made any changes at all. So back to the first step. Check the first step. X plus 11 over x plus 6 less than 3. Put in 0 in both places. So 0 plus 11 over 0 plus 6 less than 3. 11, 6 less than 3. Somebody have that in their calculator? Was that 1.8, whatever? Is that less than 3? Yeah, that's true. So we checked out here to the right, right? I was checking a point. 0 was a point in the right section. Wasn't in the middle. Was in the right section, huh? Y'all tracking with me? I go wherever 0 is. 0 happened to be in the right section. I plugged in my multimeter to check for power, and the little dial went, yep, that wire's hot. there's power there. There's truth there. So this is a true section. This must be false, and this must be true. It's the same as last time. It's true, false, true, huh? So our answer is these two true sections. We're always trying to find where it's true, right? So there it is. Negative. You always go negative infinity to negative 6, and negative 3.5 to infinity. It's A, isn't it? Is that okay? Y'all going to get the 2 greater than, less than on the test on Wednesday? I'm hoping. Does that make sense? Put those steps on your 3x5 card. Step 1, change to equals, solve. Step 2, just denominator. And then do the number line thing on step 3. No questions? I'll move on if you're good. All right. Number 14. So we got f of x is 8x plus 12. G of x is 3x minus 1. How about f of g of x? What does that mean? Yeah, one function into the other, huh? One function. And remember, functions always go right to left. So it's going to be g put inside of f. You don't need the x part. That doesn't really matter. You can do it if you want to, but whatever. It just means g plugged into f. Are we good on that? Remember that little floating O, this little floating O thing. It means one function's plugged into the other. And functions are always right into left, aren't they? Like if I go f of 4, that means 4 goes into f, doesn't it? Functions are always right into left. So that means plug g into f. What does that mean? That means take all of g and put it right in there into f. So it's 8 times all of g. So I just plugged all of g into f. All of g into f. And then so distribute 24x minus 8 plus 12, 24x plus 4. There's f of g. B, huh? Good there? You all happy? I'm aiming for your happiness. And you'll be happy when you can do these problems, huh? Is that good? Can you do these problems? Keep moving. Kind that we did the very last section, 8.7. So I'm giving you this for the sound thing. And I'm telling you I0, and I'm telling you 72 decibels. Okay, so we write L equals 10 log of I over I0. Good so far. And then it's saying what I0 is. 10 to the minus 12. Put that in for I0 there. And then, so you can really just make that, I'll just do it right now. 10 to the minus 12. Down there. Okay. So now we only have 2 letters, don't we? Remember that's how we always played the game in this word problem section? There was always 2 letters. In this case it's L and I. And they're going to give us one of those letters. They'll either give us L or they'll give us I, and we solve for the other one. So what else are they giving me? They're giving me 72 decibels. Is that L or is that I? Is that I? Okay. Yeah, let's read that real careful. Okay. Look at this part I know this sentence can be confusing. Let's look at this part right here. What is I? Let's be really clear on what I is. By I, comma, the number of watts per square meter. So I is watts per square meter, meaning it's not decibels. Does that make sense? So over here, L is loudness in decibels. I know you might look like, yeah, but it says the I stuff, well, yeah, but it's saying that's what L equals, right? In other words, see the equal sign there? Let me help you read formulas. Don't be thrown off by, the I. Well, yeah, but it's got an I. Yeah, but it's got a whole everything formula, which is equal to what? L. So that means this whole thing is really L. So whatever they say about it right here is about L. Does that make sense? Because that's what L equals. Don't be thrown off just because part of L has an I in it. That's just part of L. All of this is L. Right? This is what it says right here. Right? It says L equals. So that means L is. Meaning all of that is L. So don't be thrown off by the fact that there's some I stuff here. That's just part of the makeup. That'd be like if I said, hey, I'm talking about a class, and I start naming some people in the class. But I'm not just talking about certain individuals, right? I'm not just talking about Julio, even though he's a member of the class. I'm talking about my whole Math 103 class. That's kind of what this is talking about. This isn't just talking about I and stuff. It's talking about all of this, which is L. So what does it say about L? Loudness, decibels. So, two different ways I've shown you. Decibels is L. Decibels is L. So that means 72 is L. Does that make sense? Am I losing you? So that's L. Okay, so I need to solve that equation for I. I is there saying, I want to be alone. I'm way over here, and I want to be alone. How do we get I alone? What do we do? So here's I. He said, I want to be alone. Remember, it's like peeling an onion. You go layer by layer. So start in the outer layer. Peel the onion, right? Get on down to the I. So start with the 10. Let's peel off the 10. So that would just be, how do we get rid of that 10? Is it 10 plus the log? There's no symbol there, so it means times, so we divide, right? So divide. Because it's multiplied in front of the log, right? See the times right here? It's multiplied, so we divide. So that would be 7.2. Log of I over 10 to the minus 12. Good so far? Okay, do the next step. Let me let you do the next step. The next step is really, really important. So we're trying to get that I alone. So do the next step to get that I alone. So what's our next step to get the I alone? Get rid of the log, right? Gotta get rid of that log. So what do we do? Do we divide both sides by the log? Good. So this is where a lot of people stumble, right here. Remember, whenever you want to get rid of a log, what happens? The base stays the base, the other two switch, right? That whole special thing. Everybody good on that? That's the fundamental rule of logs, but it's easy to forget because we think you can divide or something. You can't divide by that log. You have to, whenever you lose a log, it's a special deal. It's not multiplication division. It's a special arrangement. What is that arrangement? Base stays the base, other two switch. What is the base? I don't see any number. It's 10, huh? There's another 10 there. In addition, the I 10 to the 12, 10 to the minus 12, that's just the plug into the log. But there's another 10 there that's the base that's not showing. Right? There's always a low down number for every log, other than this fraction. Right? So there's another 10 there. When you lose the log, the base stays the base, the other two switch. So meaning the 10 stays where he's at, and the other two, what does it mean other two? Meaning everything else. The 7.2 and that whole I fraction switch. So it becomes 10 to the 7.2, and the I over 10 to the minus 12 goes over there. Is that good? See what happened there? That's the major step there. I'm glad to talk further about that with you in office hours. I really have to move, though. That's super important that you understand that. Really, really important. That's the fundamental principle of logs. When you lose a log, the base stays the base. He stays put. And the other two swap. Okay, so now we have to finish solving for I. Now we just put this over 1 and diagonal, you know, cross multiply kind of thing. So let's keep going. So I'm kind of running out of room here. Maybe I'll come over here. We've almost got it. And we're going to have I times 1 equals 10 to the minus 12 times 10 to the 7.2. And then what do you do with powers? When you're multiplying, you add the powers, huh? So it'd be minus, isn't it 4.8? Minus 12 plus 7.2 equals negative 4.8. So, yeah. So then, hit the buttons on your calculator. Can you guys do that on your calculator? Do you know how to do that on your calculator? I'm glad to help with that as well. It's 10 to the power. You're going to have a power button. Depends on your calculator. They're all a little different. 10. You have x to the y, or maybe an up arrow to the negative 4.8. Hit equals. Is roughly how it is on most calculators. Mine's saying the answer. I'm getting the answer 1.58489, blah, 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 E minus 5. I don't know if you're getting something like that. E minus 5. What that means, that E minus 5, or however your calculator does it, means 10 to the minus 5 power. Exponent. E stands for exponent. The minus 5 is up in the exponent, 10 to the minus 5. So 1.58, that rounds, that's this one, huh? Rounds to 1.6, says round the nearest 10. So rounds to 1.6 times 10 to the minus 5, B on that. Is that good? Yeah. Yeah, maybe your calculator shows it as 1, 2, 3, 4 zeros and 158. So that's the same answer. Do you realize that's the same thing? So here, I'm still running out of, there's no room on this one. Yeah, so some calculators will actually show the zeros. We'll show it like this. And that's the same thing as 1.58 times 10 to the minus 5. Why? Well, what does scientific notation do? What does that times 10 to the minus 5 mean? It means take this decimal and go back, negative 5, go back 5 places. 1 jump and you're to the edge. So the other 4 jumps, 2, 3, 4, 5, the other 4 jumps bring in zeros. So 0.40, 158, is the same as 1.58 times 10 to the minus 5. So those are two different languages of numbers called scientific notation and regular to say the same number. Is that good? Remember all that? So depending on how your calculator shows it, 1.58, 10 to the minus 5, or e to the minus 5, or 0.40 is 158. That's the same thing. It's 5 places back. If you're looking at this in your calculator going, well, how do I know which one's right? Just put the decimal right here between the two digits like they have at 1.6, 1.5 and 1.6, and then go, how many places back? Oh, yeah. 1 back for the 1, and then 4 zeros, 5 places back. Yep, 10 to the minus 5. That's right. Is that too quick? I got to move. Come talk to me. Be glad to help. I always was talking to my math teachers because math is hard. Another word problem. How long will it take for the population of a certain city to grow from 10,000 to 30,000 if its annual growth rate is 4.6? Use this equation. Okie dokie, I will. So P, I don't need those parentheses, T, equals P0 e to the KT. Wow. Okay. K, what's K? Well, we did one of these problems earlier, and you guys remember it completely, right? No, we only did like 1 or 2, I know, so it's good. That's why I put in the practice exam so I could remind you. K, what is K? K is the growth growth rate, which they told us is 4.6%. And so that's K. Change that to a decimal, move it back 2 places, 1, 2. It's 0.046. So the growth rate is 0.046. What's the P0? It's the population at time 0, meaning at the start. That's whenever in a science form, if you're going to go on and take any science classes, biology or chemistry or anatomy or something like that, or I meant to say the space one, not anatomy, astronomy. There we go. Anyway, any of those, they'll often have things like something with a little sub-zero, a letter with a tiny little 0 next to it. That 0 means at time 0. So that's P at time 0, population at time 0, meaning at the start, initial population. So what's the initial, the starting population? That's the 10,000. So you want to know those. You want to put those in your 3x5 card. P0 means population at the start. K, growth rate. So P equals 10,000 E to the 0.046, that's the K, T. There we go. There's our formula. All right. Now, what's time? Well, I don't know what time is. What do I do with the 30,000?
Put it in first B.
Yeah, for the first B, because that's what the population became later. That's population, huh? 30,000 goes there for the P, the first P. Does that make sense? Everybody see what I have so far? It's a harder question. And so we need to solve that now for T. I'm kind of running out of room here. I'm going to, if you got that copy down, I'm going to go to blank screen here. All right, 0.046T, yeah. So everybody got that down? That okay? So go ahead and solve for T. So now we're at the point where it's time to, we've only got one letter, huh? Just T. So it's time to solve for T. T is saying, I want to be alone. Please start peeling the onion and get me alone. So can you do that? Can you peel that onion and solve for T there? What's the first step? Yeah, just like last time, divide that 10,000 out of there. And that's a nice clean 3. Good to there. Trying to get that T alone. Let's take the next step. So what do we do to solve for that T? Good. I told whole history lessons to help right here. This is why I told that. I don't know if it's probably why I'm not a history teacher. It was of no benefit. Huh? Remember, Hitler has climbed into power. You see, I'm trying to help you because it comes at you out of nowhere and it's hard to remember. Do you see what I mean? The letter we're trying to solve for, the only letter there, the T, where is he? He's climbed into power. Like Hitler. Crazy views came into power. T has climbed into power. So when the letter climbs into power, that's a huge deal. When the letter itself gets up there in power. Doing all I can to help your memory. Natural log. That's hard to remember, huh? Because where'd that come from? This isn't a log problem. Right. It's hard to remember. That's why I'm telling stories. Trying to help. When the letter climbs into power. If you can't make the bases the same, which we clearly can't with E, that's weird. Natural log, both sides. You have to remember it out of context because it doesn't remind you. You just have to be ready for it. When the letter climbs into power, put a note on your thing. Letter in power zone. When the letter's in the power zone, ln both sides. Why do we ln both sides? Because then that great quality of the log, Hitler is knocked out of power, right? Right before, I'm going to tell you one more story. I'm listening, I told you, I listened through Winston Churchill's biography. We just finished World War II, so I heard all the details recently. Interesting little details. Great biography if you like reading biographies. Winston Churchill's by William Manchester, very detailed. Right near the end, Hitler had about a week to go. He had his 52nd birthday party. It was 1945. He's done. Germany's done. Everybody knows it. The Russians are days away, literally 3 days away. He has his last birthday party. All the big shots come to Hitler's birthday party there in Germany. It's kind of a funny. So one of the people wrote later it was like a meeting of the dead. They were about eliminated and they knew it. This one guy, Hitler told this one guy, one head guy who came to the party. I think it was. I forget which guy it was. Anyway, maybe it was Goering. Told him to go do scorched earth. Do you know what that is in a war when they do scorched earth? He said, go blow up the rest of Germany so the Allies can't have it. That's what you just destroy your own land because you don't want the Allies to have it. Hitler told this guy, go destroy the rest of the fields, burn them, destroy the rest of the airfields, get rid of all the planes, destroy it all. He said the German people have failed their Führer. That's what Hitler said to this guy. So this guy marched out, and with, as the author read it, no intention to obey the command. Because nobody obeys Hitler at that point. Why not? Because he's out of power. Everybody knows it. Hitler's days are numbered. And so that general left with no intention. But the funniest thing happened. He got in his plane. He flew off. He did not obey the rule. He didn't destroy the rest of Germany. But a couple days later, and Hitler only had about 3 days left, he flew back because he felt bad. Isn't that weird? Very interesting story. He landed his plane. He approached Hitler, he wrote later, thinking I was pretty sure I'd be shot. He approached Hitler and told him the truth. And he said, Hitler, I didn't do it. I disobeyed your rule. What a gutsy guy. I mean, kind of strange, but I admire his guts. He told him the truth. And Hitler didn't kill him. They had a talk, and because Hitler could tell he liked him, and and they had this weird talk, and then after 5 minutes of talking, Hitler just pushed him away and said, "Auf Wiedersehen," get out of here, and he just got in his plane and flew away. Hitler never killed him. Anyway, interesting story. All right, there we go. No, that's thanks for indulging my history wannabe teacher. I think history is very interesting. So, letter and power, right? Letter and power. When that happens, L on both sides, and Hitler is knocked out of power. Then he's just a regular guy, and nobody cares what he says because he doesn't have any power anymore. He's on the base level. He's not in power. See the letter? He's just a base letter now. He's not in power. It's a big difference, right? Okay, L and E's 1. Remember that? So that just drops out. So 0.046 T, L in 3. How do you solve for T? Last step. Divide by 0.046. Boom. There it is. Hit the buttons on the calculator. That was a long problem, wasn't it? I'm telling stories and everything. What we got? I'm getting 23.88. Y'all getting that? Let's go back over that. Answer's there somewhere. Rounds to 24, huh? Rounds to 24 years. Whew. That was a long one. Questions on that one? So you can tell this test is not for the casual, right? You got to be serious about this. You got to put some time in. This is much harder than exams 1, 2, or 3. This is much harder material. Yeah, Kara.
I'm going to do 2.388.
Did you remember to do 0.046 or did you do 0.46? Oh. All right. Yes. Okay, so number 17. I'll bring it over here. 17. Log base 3 of 9 is x. We'll try that one. Solve for x there. So what do we do on this one? What do we do? Anybody? Nobody knows? Lose the log. What happens when you lose the log? Base stays the base. Other two says 3 to the 9 is 3 to the x. 9 goes over there. Right? Whenever you cross out a log, remember? Base stays, other two switch. Okay, so then what does x have to be? 3 to what power is 9? What does x have to be? 2. 3 to the second power is 9, huh? X is 2. Oh, it's not there. None of the above. It's disturbing. It's like going back to tell Hitler you didn't obey his command. It's disturbing. All right. We good with that? Now, the other ways you could have just done, remember how we learned to make it into 2 logs? You could have done that. You could have said, look, I'm not going to do any x move around stuff. I'm just going to do log 9 over log 3. Remember how we learned you could make the top go to the top, the bottom go to the bottom? You could turn 1 log into 2. Whoops, that's not what I meant to erase. I meant to do this one a little better. Remember that? The top goes top, make it into 2 logs, hit the buttons, that'll tell you 2 also. Oh, ln will work as well. Yeah, I said ln, huh? Yeah, ln 9 over ln 3. That'll do it too. That'll also be 2. Yeah, either one. Regular log, ln log. Got to do them both same. But yeah, either way. You can always do that. Remember that rule? We can make it 2 logs. The top goes top, the bottom goes bottom. So many rules, huh? A lot of material. A lot of material. This is meant to weed out those who will discipline themselves. You can all do this. You can all pass this. But it's those who will put in the time. It's funny, we were talking, it was a week ago, 2 weeks ago, some of the math, I was at some meeting. Oh yeah, I was at a meeting 2 weeks ago with the vice president of the school, and we were having a meeting about how to help people do better. And we were talking, there was this big official guy came in that helps colleges raise their pass rates and everything. And we're all talking about, why is math in the curriculum? Why do we do this? What's the purpose? And it's everybody says and knows the state of California does this because they want to weed out those who will not discipline themselves. That's it. That's really it. So know that's what everybody's looking at you at in these classes. Your grade will say, I am willing to set aside my life and I can control myself and discipline myself to make study and one day my job a high priority and work hard over material and pore over it and learn details and put them together. All that discipline is what an employer wants to see. It's what the state of California wants for employers. So know that, discipline yourself, and you can make it. All right. Let's try that one. It's always funny when I'm giving those speeches and people walk out. I'm not. It's fine with me. She probably had other important priorities. I mean, it's just kind of funny. All right. Try that one. Oh, that's supposed to say equals 0. There's a little mistake there. That should say equals 0. Equals 0. Remember these kind? I got to really speed up. These take forever, don't they? It's a long test. Anybody remember? This is a very specific kind of thing. The U kind. Yeah. We're going to do a bunch. Well, yeah, this one's going to be the same thing. These 3 are all going to be U problems because they have high powers and weird powers. Remember that? There's a lot to remember. You want to put in your 3x5 card. If you have, like 4th power, which is what we have on this one, right? 4th power. Or like negative powers, which is what you have on this one. That's a negative power. I mean, that's weird. Or this one, big old parenthesis pieces. And, when you have those kinds of things, what do? That you let u equals the middle, u squared in the front. Remember that whole thing? U's the middle, u squared's the front. So the middle becomes u. The front becomes u squared. Remember those kind? There's 3 of those, notice. You got to really know these. That's a grade and a half, probably. It's a lot of points, whether you know the u stuff. We spent a lot of time on it. It's only fair that it is. A lot of points. It's a lot of what we spend our time on. But it's hard. I'm telling you, because a lot of people tank on it. You can learn it, but it's not going to come to the casual. You've got to spend some time on it. So you can do these, but they take practice. So, okay, so the middle becomes u, the front becomes u squared, and then you just solve the u like normal, which would be factor. So let's factor this thing now. So 9 and 2, both minus, like that, right? Because that makes minus 11 in the middle and plus 18 at the back. Is that good? They multiply to be 18. They add to be minus 11. That good? And then that means, positive 9, positive 2. And so now I'm done with the u stuff, but at the very end you've got to go back to your original letter. Remember how that works? So I'm going to go back to my original letter. Everybody good so far? Am I going too fast? Now, how do you know how to do that? Well, again, where did the u show up? Middle. The u is always the middle piece. That's always what we do on every time, no exception. U is always the middle, u squared is always the front. So if that's the case and it's time to go back, and you're wondering what u is, well, u is the middle. Whatever was in the middle, x squared is 9, and x squared is 2. And you know how to finish that, huh? Just square root it now. But what happens when you put a roof on the house? Up and down the ladder, right? Plus or minus? Root, plus or minus. So the answers are plus or minus, what's square root of 9? 3, and plus or minus square root of 2. We can't root the 2, so we just keep the root on it. But we can root the 9, so we root the 9, it becomes 3, and the root vanishes. So plus or minus 3, plus or minus root 2. There it is. Answer C. Is that okay on that? We'll do 19, and then we'll do 20 and 21. It'll be 2 more U problems. To 19 now. So try 19. Log base 5 of x is negative 4. So again, lose the log, right? Just cross off that log. Base stays the base. Other 2 switch. So the base stays the base. Other 2 switch. So instead of 5 to the x power, it's 5 to the negative 4, and the x power goes over there, like that. We good to there so far? Okay, and now what do negative powers do? Yeah, negative powers flip things, don't they? So negative powers flip. So 1 over 5 to the, and that'll be positive 4 after the flip like that. And then use your calculator. 5, that bottom is 5 times 5 times 5 times 5. 5 times 5. And that is 625. Bless you. 1 over 625. B. Yeah, remember, so the main lesson here is negative powers flip things. They don't put negative in the front. I hope that's really comfortable for y'all, because that'll be tested on several problems on this test. Negative powers flip, don't they? Let me write a note on that. Negative powers flip things. They do not put negative in the front. They flip things. Is that good on that? I'm going to try number 20 on that. Oh, yeah. It's not actually due till after the test, so don't even worry about it. You can keep it. You don't need to. It's useless till after. Thank you. Yeah. So try number 20. Number 20 is a U one again, right? Let U be the middle. That whole middle, this whole middle parenthesis chunk becomes U, and then the whole front becomes U squared, right? On number 20. thought we'd get through this practice in like maybe 45 minutes. It's taking forever, huh? These are long problems. So the front becomes u squared. The middle becomes u. That's what we always do when you have the big parenthesis chunks or the weird powers. Fourth power, negative powers. Always do that. And then factor from there. So what would that be? How do you multiply to be 2, add to be negative 3? Negative 2, negative 1? Yeah. Those will multiply to be plus 2 and add to be negative 3. Good. And then so it's u is positive 2, u is positive 1. And then how do we go back now? So that's the end of the u. We got to go back to the original. Where do we go always when it's time to go back? The middle. Yeah, remember u is always from the middle. So that'll be exactly x squared minus 4 is 2. And x squared minus 4 is 1. Is that good? The middle. Okay. So now, how do we finish solving for x there? So x squared is 6. And then root, and plus or minus, as you know, roof on the house, up and down the ladder. Add 4, add 4. X squared is 5. Root, plus or minus. So plus or minus root 5, plus or minus root 6. Answer A. There we go. Good. Want to try 21. Same thing, huh? 21's another u problem. The middle is going to be u. The front is going to be 6u squared. How do you know? Because it's got weird negative powers. So negative powers or fraction. We did some fractional power ones in the homework, which is what could be on the test. I don't even remember. Fractional powers, negative powers, big powers like fourth power, or those big parenthesis repeated chunks. Those are all u problems. Middle is u, the front is u squared every time. So here we go. So the front is u squared. The middle is u. Now, how do you solve that? Did you guys do the quad? I'd probably do the quadratic formula. I mean, you could if you're really good at factor, that is factorable. It's hard though, but some of you are good factors. Then go ahead and do that. I found most students prefer to just do the quad, so I'll just do it that way. The ABC quadratic formula thing, you know. So negative b plus, we put this on your 3x5 card. We need the quadratic formula even in this chapter also. Negative b in this exam. Negative b plus minus square root of b squared minus 4ac all over 2a. So that's negative 17 plus or minus the square root of b squared minus 4 times a times c all over 2a. We good so far? Two negatives is positive. 17 squared is 289, I think, right? And then this is going to become plus, is it 72? Yeah. Everybody see how I got plus there? Right? Because negative times positive times negative, two negatives, positive. And so, where does that bring us? That brings us 17 plus or minus 289 plus 72. What's that?
361.
Okay. Wait, one more time. What was that? 361. Thank you. 361 over 12. Then you square root the 361. I think it's something nice, isn't it?
19.
Ah, good. So that's 19. So 17 plus or minus 19 over 12. Let me slow down there for a minute. Does everybody see where we're going with this? So negative times negative. Two negatives makes positive. So I worked it all out, square root of 3, 6, 19. Then you just do the two options. 17 plus 19 over 2 and 17 minus 19 over 2. Or 12. 12, huh? So what is that? 34, 36 over 12. So 3. First one's 3. And the second one is negative 2/12. Reduce that, negative 1/6. And we're still not done. That's the end of the U work. We got to go back to the original letter still. But is everybody good to this point? So we've got, so far, the two answers, 3 and negative 1/6, which they're trying to sucker us in with option D. They're baiting the hook. We will not bite, right? That's not the answer. We're not done yet. That's just the U work. We've only solved the U equation. Now we have to do the second phase where you go back to the original letter. You guys okay with, you tracking with me? So now how do we go back to the, what do you always do? Always on these U problems. Go back to the middle. What was in the middle? K to the minus 1. So that means that it is K to the minus 1 is 3, and K to the minus 1 is 1/6. Right? I'm going to get this out of the way here. I don't have any room. So, right, because this was U before. These are the two answers for U. We had U is 3, and we had U is minus 1/6. Those were U answers. That came from solving this U equation right here. So then you go back and say, what is U, though? U is always the middle. So that means it's K to the minus 1 that's 3, and K to the minus 1 that's minus 1/6. Okay? Now what? How do I go from K to the minus 1 to regular K? I just want regular K. You could. I showed a technique by saying, look, whatever they have up there, just ask yourself what times negative 1 will make positive 1. Because that's what regular K is. K to the positive 1, isn't it? So negative 1 power. Whatever you do to one side, do to the other. You do both sides to the negative 1 power. Why? Because negative 1 times negative 1 right here is positive 1, or regular K. That's what will turn it into regular K. What is regular K but K to the positive 1? Make sense? So when they have a negative 1, you need to multiply by another negative 1. Two negative 1s will make positive 1. Whatever you do to one side, you got to do the other. So what is 3 to the negative 1? Negative 1/3? No. I hope you know that's a no. What am I doing wrong there? It does not make it negative. But they're going to try to fool you with all their options on that. They're testing hard whether you know that rule. What does a negative power do? Does it change signs? No. It has no involvement with signs in the front. It only flips. If the thing started positive, it's still positive. It has no involvement with signs in the front. It just flips, huh? Same thing here. Both sides to the negative 1. It'll flip it. 6 over 1, which is just negative 6, but it won't change the sign. It stayed negative. So negative 6 and 1/3. B. There it is. That's a tough one. As I always say, that won't come to the casual. It's not about being smart. It's about putting the time in. You can master that, but it takes time. You got to practice those. You got to go back to the homework, do 3 or 4 of those in a row. Make sure you can really do it. Look back at the YouTubes. All the help is out there for you, but it takes time. Lots of time. Questions on that? We got to finish. All right, so log base 5 of 1/25. Remember how we learned to do 2 logs? Let's just do that. The top one goes top, the bottom one goes bottom. So just make it log of 1/25 over log of 5. The top one goes top, the bottom one goes bottom. Hit the buttons on your calculator. Isn't it like -2 or something? Yeah, it is -2. Y'all getting that? So it's D. That okay? Can I whip on through that one? If you have any trouble with your calculator, come see me. Be glad to help. This will be the last time before the test. There's never a none of the above option. So that's nice. It is one of those 4. There's no E option. It is one of those 4 graphs. Which one is it? How do we do all the graphs on this test? Table. Totally. Make a little table. Make a little XY table. Usually you probably only need 1 point a lot of times, sometimes 2, to tell which graph is right. What am I going to plug in for X? What's the easiest number you know? 0 and then 1. Usually that'll take care of it. So plug in 0. Now f of x, what do we do for f of x? That's y. That's y equals e to the minus x plus 5. So plug in 0, e to the 0, or -0, whatever, same thing. What's anything to the 0 power? 1. So 1 plus 5 is 6. That's all we need. We're done. Which one of those 4 graphs has the point over 0 up 6? Let's find it. I'll go to A. Over 0 up 6. Here's over 0 up 6 right here. And the graph is missing it, so it's not A. Here's over 0 up 6 on B. And the graph on B is missing it, so it's not B. Here's over 0 up 6 on C. And the graph is missing it, so it's not C. Here's over 0 up 6 on D. And the graph hits it perfectly, so it's D. See how easy that is? Just 1 point took care of it. I just plugged in 0. Found the point 0.06. Sometimes you need 2 points, but that's all it took on that one. Is that okay? All right, so y equals 1/2 to the x plus 2. What are we going to do in all the graphers? Make a table, right? So make a little xy table. Put in 0, put in 1. Am I going too quick? Anything to the 0 power? Is 1. 1 plus 2 is 3. So is that enough? Over 0 up 3. Yeah, that's enough. Only one graph has the point over 0 up 3. Which one is it? See, right here. Here's over 0 up 3. See how the other ones miss it? Here's over 0 up 3. A missed it. Here's over 0 up 3. B barely missed it. Here's D over 0 up 3. D missed it. They all missed it except C. Answer C. Next problem. So the graph ones are easier on this test than all the other ones. Just make an XY table. Plug in 0 and 1. Shall we go to the last one? Okay. Yeah, this one, log base 4 of 62.5. Just use your calculator. Remember, the top goes top, the bottom goes bottom. Just make it 2 logs. You can do 2, like Abraham was asking, 2 LNs or 2 regular logs. It'll work either way. The top goes top, the bottom goes bottom. Hit the buttons on your calculator. You will get it. and you get 2.98. There it is, D, 9838. All right, we good? There is